Okay. So our first, remember our goal is we want to get zeros all in this bottom corner, and we want these to all be ones. So getting the ones part is easy because at any time we learned that you could divide a row. So if it's not a 1, we can just simply divide the row by that number, but we want to wait to do that till the end. Okay? So, I want to get a 0 here, and I want to get a 0 here. Ooh, right away I noticed something. What could I do to get a 0 pretty easily in the bottom row? How could I get a 0 here? Just add row 1 to row 3. So the nice thing about row echelon form, or when you have things in an augmented matrix, is it saves us some space because we're not always writing the x, y, z's out. Okay. So if I add, and I'm not going to write this down separate because we can do this. Let's add row 1 plus row 3. What's 1 plus negative 1? 0. By the way, I'm going to be putting this back now into the bottom row. What's negative 1 plus 2? 1. What's 2 plus negative 3? Negative 1. Negative 3 plus 7? 4. So I just added row 1 and row 3, and that's what I put in my bottom row. I'm not going to change the other 2 rows yet. All right, so now I want to get, and I could have done the 0 here first if I wanted to. Now I want to try to get a 0 there. What could I do, what operations could I do to get a 0 here? Very good. So I'm going to do negative 2 times row 1, and I'm going to add it on to row 2. Okay. And then to save some room, I'm going to just, and I'm using a different color, but you could just do it smaller. Right above row 1, I'm going to multiply what it would be if I multiplied it by negative 2. Okay? So if I multiplied this top row by negative 2, I would have, this would be a negative 2. What would this be? 2. What would this be? Negative 4 and 6. Okay. What I'm going to do now is I'm going to add that on to row 2, and I'm going to put it back into row 2. So here we go. What's negative 2 plus 2? 0. So I'm going to put a 0 right here. What's 2 plus 1? 3. Negative 4 plus negative 1? Negative 5. 6 plus 0? 6. And once again, then I'm going to fill in the matrix with what was there before. So this was 0, 1, negative 1, 4. This was 1, negative 1, 2, negative 3. Okay. Any questions so far? Molly?
What if it was like the other one and you had to multiply both of those two?
Yep. You could. Yep, you can multiply. Sometimes it's going to take multiplying both rows by something. All right, so now, remember I have a 0 and a 0. That's great, but I need a 0 here. And so because I don't want to go back to the top row, because if I added this back in, then that would mess up my 0 here. So now I want to work with these 2 rows. Really? What would I do? I'm working with the bottom 2 rows. So we're going to do, you're saying let's do row 2. I'm not going to do anything with row 2, but I'm going to multiply negative 3 times row 3. Is that what you're saying?
Yeah.
Okay. I'm gonna write those values just below here. So just because I don't want to screw that up. I know I'm sure we could probably do it all in our heads, but negative 3 times 0 is still 0. This would be negative 3. Negative 3 times negative 1 is 3. And this is negative 12. And this is finally, I'm almost there to my row echelon form. Alright, squeeze it in here. So let's add, remember, I'm going to add that to the row 2 then. So we have 0 plus 0, which is 0. 3 plus negative 3 is 0. Negative 5 plus 3 is negative 2. And 6 plus negative 12 is negative 6. And then I'm going to fill in okay. So then one last thing that I want to check, and actually, like, there's a lot of different row echelon forms, because remember how you could swap 2 rows at any time? Because if you chose to swap 2 rows, then you might have put this up there originally because there was a 1 there already, but I don't like to do that. I just then like to look at the end, and remember on the diagonals we need to have 1. Okay, well, this is a 1, which is great, but that's not a 1. So here's what you do. One of the rules of Gaussian elimination, remember, was at any time you could multiply or divide an entire row by something. So what could we divide this entire row by? 3. And what could we divide this entire row by? So the last thing I'm going to do is I am going to do row 2 divided by 3, or you could write times 1/3, and I am going to do row 3, what did we say we're going to divide? By negative 2. So let's divide these values by a negative 2 here, and we get 0, 0, 1, 3, correct? Okay. All right, and then let's divide this by 3. We get 0, and I'm going to just leave them as fractions if I need to. 0, 1, negative 5/3, and what's 6 divided by 3? 2. And then 1, negative 1, 2, negative 3. Okay. So, since these are all 1s, and then these are all 0s, this is not reduced, but it's just a row echelon form. Okay. Once again, it took us 3 and then some division to get there, and hopefully saved us some room. What does that mean then? Because sometimes I'll just say find a row echelon form, and then you're done. This I said solve the system by finding a row echelon. So what does that mean? Yeah, this is my x row, my column, x column, y column, z. All right, so z equals 3. And this up here means that x, not x, because the x is up here. This means y minus 5/3 z equals 2, correct? So let's find y now. Y minus 5/3 times 3, that's nice, because what happens with the third and the 3? Yeah, which is y minus 5, and then what should I do? Add 5 to both sides, right? So now we get y equals 7. And finally, to the top row is x minus y plus 2z equals negative 3. So we're going to write x minus 7 plus 2 times 3 equals negative 3. Let's see, that's negative 7 plus 6. That's x minus 1 equals negative 3. Then we add 1 to both sides. Brings us back to our algebra days. Good. Okay, so the solution, so this was our row echelon form, and the solution is negative 2, 3, no, 7, and 3. Okay. So the row echelon form is not the solution matrix, but it would allow us to find the solution. Yes?
For the last part when you like put all the ones in, you divided row 3 by 8 and row 2 by -.
No, I divided row 2. I need this to be a 1. What is it right now?
3.
So I divided row 2 by 3, so that that made that a 1. And then this was a -2, so I divided row 3 by -2 to make it a 1. So that division part is only to get 1s on the diagonal, if there are not any. We didn't need to do the top row because there was a 1 out there, already there. Okay? Yeah?
When you're adding something with 2 rows, like the R2 plus -3, R3,
Yeah.
how do you decide which row the product is going to go into?
You want it to be a 0.
Okay.
So this was a...
Remember when you're trying to get to 0, it's going to fill in there?
Oh, where do I replace it with?
Yeah.
Yeah.
Okay.
So I wanted a 0 right here,
Yeah.
and so I was multiplying, but yeah, typically, the one that, that you're trying to get a 0 in, that's where you're gonna put it back in for. Swap it back in. And really, some people start flipping rows around because they can see, oh, this is like an easier one to work with in row 1, but usually I just keep them as they are and just work with whatever they are and not try to swap them.
Okay.
Okay,